In this video, we'll be going through some of the assigned problems in Connect that correlate with your end of chapter problems. The first one is problem number 5-1 at the end of the chapter. In the dark shaded green cells, I have changed the data from what you'll read in the problem. The light shaded green cells are the data given in the problem. The grayish purplish colored cells are the intermediary calculations, and the yellow shaded cells are the final answer. Well, in the first case, we have a couple of machines we're thinking about buying, and they have different price tags and different cash flows associated with them. The first machine has a purchase price of $49,000 using my numbers, again the dark shaded cells. Green cells are an alteration of the data that is given. That's a negative cash flow since it's an immediate payment of $49,000. We do get some recovery at the end of 10 years of $5,000, but that's not worth $5,000 today. That's worth $5,000 in 10 years. So we have to discount that back to today for 10 periods. And again, that's a positive cash flow. And then we have another negative cash flow. These are the annual maintenance payments, and since they're all the same every year, that's an annuity. And we need to find what the present value of that annuity is too. Then we'll add them together. So if we jump down to the answer here, the purchase price is a current cash flow, so there's no adjustment needed there. Present value of the salvage value is $5,000, positive cash flow, discounted back at 8%. So we enter 0.08 in the Excel rate function, and then the Excel rate argument, and then we also have to enter the payment amount, which is a negative $5,000 future value. So that's worth $23.16 on the positive side. Finally, what is the present value of the negative cash flows of $1,000 per year, discounted back 8%, number of periods is 10, and we wind up with a negative cash flow of $67.10. Add them together then, two negatives and one positive, and the cost of machine A in total is $53,394 using my numbers. The second machine is a little different. We have an immediate negative cash flow or purchase price of $39,000 using my numbers. No salvage value in this case. We have maintenance costs, but they're different amounts. So we can't use the annuity function. We have to use the present value of one or lump sum and then calculate those present values separately. Again, discount period is 10 years, and we're discounting back at 8%. So scrolling down to the present value of machine B, negative $39,000, no salvage. And then we took the present value of the negative cash flows of these maintenance costs. So the first one was only $4,000. Discount that back 3 periods, since that will occur in year 3. Next one is the maintenance cost in year 6, so we'll discount that back 6 periods at 8%. Future value, of course, is the $5,000. That's a lump sum payment. And we'll do the exact same for the year 8 maintenance costs and discount that back 8 periods at 8%. And we wind up with the present value of those 3 future negative maintenance cash flows are as given, and we'll add them all together then, and that is the cost then of machine B. And then finally the final answer is which of these machines should we purchase? Well, just take the lesser of the two, and that is machine B in this case. Moving on then to problem number 5-3, which is another Connect assigned problem. We have some investments that we can look at, and here we're thinking about investing in equipment. So we have 3 options. We can pay $1 million immediately. So the $1 million needs no discount. We don't need to discount that at all because that is today's present value. We're paying it now, $1 million. Option 2, we can pay $420,000 immediately, And then we have annual installments of $80,000. So that's an annuity, since they're all the same. That's an ordinary annuity. It comes at the end of each period. And then 10 installments. So what I've done in this case then is I've just taken the present value of the $80,000 annuity for 10 periods at 8.5% using my number, my adjusted number. And then I'm going to add that to the 420. So the present value then of option 2 is 944,908. And as always, feel free to stop and replay various parts of this video if you'd like to spend more time and reinforce your understanding of the concepts. And then finally, option 3, we're going to pay $1.5 million, but not for 5 years. So that's the present value of a lump sum. So we'll take at 8.5% using my interest rate or discount rate. Number of periods 5, and then the future value is negative 1.5 because we're going to pay that in 5 years. So what is the value of that negative 1.5 million today? We're going to have 997,568 using my numbers. And then of the 3, we'll select the one that's the least costly. And in this case, it's option 2. Problem 5.6 at the end of your chapter, in chapter 5, I've changed the interest rate in this case. These are 3 independent situations, so they have no relationship one to the other. And I've solved them in 2 manners, because I know some of us like to use the tables. So I'm going to show you how to use the tables to find the number of periods. You can also use Excel or your calculator or your online calculators as well to calculate the number of periods. So we're given that they have $30,000 in the bank. They want to arrive at 60. That's the future value they'd like, that Jameson would like, I should say. And we're going to have an interest rate of 8.5% using my adjusted interest rate. There's a function in Excel called NPER, number of periods. We'll use that function then and just enter the data as we always have. And it turns out if we round it, it'll take about 8 periods using my discount rate. All right, now if you're using the tables, the first thing you need to do is to calculate the factor. So I took the 30 into the 60,000, and that gave me a factor of 0.5. Now I go to the present value of 1 or lump sum table, and I look and I say, okay, I know that the rate is 8.5%. So if I had an 8.5% column, I can go to that column, and I can just start looking straight down the 8.5% column. I realize your table doesn't have an 8.5%, but if it did, you would look down 8.5% column, and then you'd stop when you arrived at the factor of 0.5. So all those factors that populate these tables, these time value of money tables, these factors are used in this case to determine the number of periods. So go down the column of 8.5%, stop when you get to a 0.500, and then look to the left and see what row you're in. And you'll be in row 8, which is 8 periods. We do the same thing for 2, but in this case we want to find the interest rate. So again, using Excel, there's a function called the rate function, R-A-T-E, when you're trying to find the rate. Enter the data as you have been in the past, and it'll calculate at 9.63% using my adjusted payment amount. If you're using the tables, you need to make a calculation first. In this case, you're going to take 28,700 and divide it into the payment amount of 7,500, which is adjusted, and you'll wind up with a factor to go to the tables now of 3.827. Here, though, you're going to need to use the present value of an annuity table because this is an annuity. This is a regular payment. So if you go to the present value of PVA, present value of annuity of 1 table, you know your end is 5. So go to row 5. Once you're in row 5, then scroll over to the right and stop when you get a factor of 3.827, and you'd find that you would have an interest rate of 9.63. Now, I realize your tables aren't this precise, and so you don't actually have interest rates that are broken down in this fine of detail. So we'd have to use a process called interpolation. But for those of you using the tables, using the data that's actually given to you in the problem, you will have a factor that aligns almost exactly with the interest rate that you need. So you'll be able to look up, go to row 5, scroll over to the right, and then you'll find your calculated factor, and then look up at the interest rate, and you'll find one that matches almost exactly. Because I changed the values here, I came up with a number that was not a whole number, a whole interest rate. Okay, so that's how you can use the tables to calculate the interest rate. You got to calculate the factor first, as demonstrated, and then once you have your factor and you have your number of periods or your row, you can find your column or your interest rate. In the last example, we have Robinson borrowed $10,000 from a friend. Here we want to know the payment amount. I've changed the number of periods to 11. 9% is given, and then the present value is $10,000. Here in Excel, you can use the payment function, PMT. Enter your arguments as always, and you'll wind up with a payment amount of $14.69. So here we're going to use the payment function. If you're using the tables, however, and you're trying to find the payment, what you'll need to do is look at what's given. You are given the interest rate, and you're given the number of periods. So you'll go to the interest rate and number of periods in the table, and you'll find the correct factor, 6.80519. And then you'll take that factor, and then you can calculate the correct payment amount. So for example, if you took $10,000 and divided it by your factor amount, you would wind up with $14.69. So I'll just leave that in there. Again, I took 10,000 divided by my factor, taken from the table at the intersection of 9% and 11 periods. And then once I got that factor, just taken right from the table, then I divided that factor into the 10,000. And that gave me the payment amount. Moving over to the next Connect assignment problem. In this case, it's actually an exercise. We're asked to look at the return on investments using assumed data. So you're given an interest rate on the first investment. I changed it to 8.5%. Compounded annually. The adjusted rate for investment 2, however, is a quarterly adjustment. So what I did is I took the annual interest rate and divided it by 4 because the second investment is compounded quarterly. Change that to investment 2. So investment 2 is compounded quarterly, but we had to adjust investment 1 to find it. So it'd be similar to investment 1 compounded quarterly. That it's really just another way of saying the same thing. And so we'll have to divide the 8.5 into 4 to get 2.13% quarterly rate. And then we have to make one further alteration or adjustment to the second investment. If there are 4 payments or compounding periods in the same year, then we have to take the 1 for 1 year and multiply it by 4. So investment number 2 has 4 periods. Investment number 1 has just the 1. So if you were to look at these again, you'd say, okay, investment 1 has 8.5% for 1 period. Investment 2 has 2.13% as a discount rate for 4 periods, or 4 quarters in a year. Present value is given at 10,000. Now we can go ahead and use our future value function to calculate what the future values are. So the future value then of investment number 1 is $10,850. The future value of investment number 2, again 4 periods at 0.02125%, rate rather, excuse me, or 2.125%, is $10,877. All right, so we look at the future value and we see, using my numbers, that investment 2 is larger. And so we'll accept investment 2 using my adjusted interest rate. Brief exercise 5-6, Leslie McCormick, spring quarter of her freshman year. Her and her friends are planning on a trip to Europe. They're going to go, it says here that she'd like to contribute savings over the next 3 years. I changed it to 4 years. So we will update the verbiage on the problem here. And then we have the number of quarters over 4 years is 16, right? 4 quarters in a year times 4 years. 4 times 4. Assumed rate of 4% quarterly. 4%, which is compounded quarterly, I should say. So if this is our annual rate, compounded quarterly, then the quarterly rate is 4% divided by 4, which is 1%. So now we have our quarterly rate, which is 1%. We have our number of quarters over 4 years at 16. 4 quarters times 4 years gives us 16. And then the payment made at the beginning of each quarter. So this is an annuity due problem. So if you're using Excel, we have to do one additional change to our future value function. The rate is 1%. Number of periods is 16, as we said. The payment is 500, which is given. However, under type, the argument type, we have to change that 0, which is the default, which is for an ordinary annuity, the annuity coming in at the end of the year. We need to change that to a 1, and that will toggle it over to an annuity due, where the payment comes at the beginning of the period. And once you do that, you make that adjustment, then you have your future value, which is $87.15. So in this case, it's just a matter of remembering to convert your annual rate to a quarterly rate and the number of years to the number of periods, and then be sure to toggle that function to solve for an annuity due problem and not an ordinary annuity. You can do this also in the tables. In the end of the text, they actually have present value of annuity due tables. So just make sure you select the correct table if you're using the tables. And then finally, I have a notation. There's 2 brief exercises that I have not demonstrated here because they're very similar to ones I've already shown you. So there's 2 brief exercises that cover material that we've already discussed in this video. If there are any questions on these or any of the problems or concepts in the chapter, please let me know.